during the last session, during the last class, we discussed about two programs which uses array for doing some special operations like finding the sum of the elements in an array, then sorting the elements in an array using the bubble sort procedure. So this we have already discussed. Now we will discuss another problem, another program we will discuss. In this program, what actually we does is we check whether a particular element is present in an array using the linear search. This is the linear search algorithm which we have already discussed in the first module itself. The algorithm for this, the flowchart and algorithm, pseudocode, etc. For this particular program has already been discussed. In the case of a linear search, we have a number of elements, say 1, 2, 3, 4, 5, 6, etc. We have a number of elements. Then what we want to do is we want to find out a specific element, say X, whether X is present in this list or not. That is what we want to do. So in order to do that, what the linear search actually does is it compares the first element with the X, and then if X is equal to 1, that means if X is the value that is to be found out, and if X is 1, so 1 is equal to 1. So obviously it is found out. So it gives out a message that this particular element is within the list. Then if this is not equal to X, then it checks for the next element. X is compared with the next element. If X is equal to the second element, then again, then it will give you the output. So only once it is found out that this particular element is present in the list, then it says that this element is present in the list, and the program is terminated. That is how it is being done. Say we have a list of certain integers, say 55, 72, 8, 19, 28. So these are the list, 5 element list. And what we want to find out is we want to find out whether 33 is present in this list or not. Then first the 33 is compared with the 55. So 33 is not equal to 55. Then it moves on to the next item in the list. The next item in the list is 72. 33 is compared with the 72, so it is not equal. Then 33 is again compared with 8, so it is not equal. Then 33 is compared with the 19, it is not equal. 33 is compared with the 28, it is not equal. So likewise, if there are say 1000 numbers, with all these 1000 numbers, this particular value will be compared until the comparison will be done until this particular value is found out. So instead of 33, suppose we want to find out 8, whether 8 is present in the list or not. So it is first compared in the linear search. What it does is the 8 is first compared with the 55. Sorry, 8 is not equal to 55. So we cannot say that 8 is present in the list. Then it is compared with the 72. So 8 is not equal to 72. Then 8 is compared with the 8. So 8 is equal to 8. So these two are equal. So that means the value 8 is present in the list. Once it is found out that that particular value is present in the list, then it breaks the entire program. That is, the program is terminated, saying that this particular element is present in the list. But instead, if it is 33, if it was the case of 33, then it is found out that till the end of the list, it is not found. Till the end of the list, the particular element is not found out. So in that case, what it does is that it says that this particular element does not exist in this list. So, and it terminates the program. So this is how the linear search works. That is, searching one by one That is, one element in the list at a time is compared with the key, the value that is to be checked, whether it is present in the list or not. So now let's move on to the program, how this can be programmed. That let's see. Sorry. So this is the program for linear search. So obviously, as in every case, we first start with the hash include stdio.h. Then the function main begins the program execution. So it is int main void. So you know that int is the return type and void is the type of the parameter that is to be fed into that particular function. In this case, since it is void, that means no parameter is entering into the program. So now we define the particular number, the list in this int A20. This is declaring our list. We have not entered the values of the list, values inside the list, but instead we are just declaring the list. Then another integer variable, that is n, is declared, then x is declared, I is declared, then found equal to 0. That is declared as well as initialized. And what are the uses of each of these? Let us see. So this n is for the number of elements in the list. The maximum number of elements in the list is 20, because the list is defined as, or the array is defined as A20. So 20 elements, a maximum of 20 elements is possible inside the array. Instead, what we do is, we put another variable n, a user input variable. The user has to input how many elements are in the list. So that is here. This statement displays how many numbers in the list. So it should be the number of elements in the list should be less than or equal to 20. The maximum possible value is 20. Then we are reading that particular value. That is why scanf comes here. Scanf actually reads the value from the user input. The user is typing the input, typing the value in the keyboard, and the program reads that particular value into the variable n. So that is why this ampersand n comes. So n is getting the variable, the value for the number of elements in that particular list. Then it displays another message, put the number of, enter the number of, enter the elements or enter the numbers. So the different elements within that array is entered. Then each of these elements is scanned, or each of these elements is read into ampersand AI. Ampersand AI means the element in an array, element in the array A. So I means ith array. The index I means ith element in the array. So the value of I starts from 0 to n minus 1. 0 to n minus 1, because there are n elements. So the index varies from 0 to n minus 1. So that is why it is I equal to 0. That is the 0th element is the first element. Then I should be less than or equal to n minus 1. That is the maximum possible index in this case is n minus 1. Say if n is 10, the maximum possible value of the index is 9. So that is why it is a of, I less than or equal to n minus 1. Then I is increased. So using a for loop, we are inputting the values that should be the elements of the array. Then another message is displayed on the screen. Enter the number to be searched for. Enter the number to be searched for. This is the key element. That is what element should be searched to find out whether it is present in the array or not. So that is this case. Then this particular value is displayed. This particular message is displayed on the screen. Then it scans. The program scans the value for x. So x is the variable that stores the value that is to be found out. X is the variable that stores the value that is to be found out. So in this case, the scanf statement is, you know that scanf is within bracket %d. %d is for, this is the type specifier. Since the value that we are entering should be an integer, it should be an integer. So that is why it is %d comes out. Then that value is, the value of that integer is stored in the variable X. Then what we do is we check, we start another for loop. This for loop is to trace through each element in the array. To trace through each element in the array for I equal to 0, I less than n minus 1, I plus plus. So the value of I varies from 0 to n minus 1. That we have already mentioned. The index of the array indices should start from 0 and end with n minus 1 if there are n arrays, n elements in the array. So that is why it is I equal to 0, I less than n minus 1, then I plus plus. Then we check for each element. For each element, we check whether this particular element is equal to X or not. If X equal to A of I. If X equal to A of I, then if it is equal, then we put found equal to 1. Initially found was equal to 0. Found was actually originally it is declared as, or it is initialized as 0. But when X becomes equal to A of I, if X becomes equal to A of I, the found value becomes 1. So the found is equal to 1. Then if found equal to 1, that is if X equal to A of I, we break. This break statement breaks the entire program. Not the entire program, breaks this particular for loop. That is the control of the program comes out from this for loop. So no more comparison will be executed. Then once this for loop is ended, that is if either this break causes the termination of the for loop, or the value is not found in the array, and thus the for loop terminates. So once the for loop terminates, we check if found. If found means if found is greater than 0, or if found is not equal to 0. This actually, if found means if the found value, the value found or the variable found is not equal to 0. If found is not equal to 0, then we say that the %d is in the list, that is the X value. The X value is in the list. So in order to display that the X is in the list, what we do is we use a printf command, then the bracket starts, then double quotes starts /n. This is a new line character. The control goes to the next line, and in the next line it prints %d is %d is in the list. So instead of %d, what it prints is the value of X. The value of X will be printed here. So that particular value is in the list, that will be printed. Else, if found is equal to 0, else means if found means found is not equal to 0, else means found is equal to 0. Found is equal to 0 means this particular condition has not satisfied at any point of the time or at any point of the iteration. So that is how the found can be equal to 0. So when found is equal to 0, %d is not in the list. That is the value X is not in the list. So in order to display it, what we do is printf, then the curve, the braces starts, the brackets starts, then within the double quotes we insert a /n. /n is for the new line character, that is the control is taken to the next line. Then %d. The %d is replaced with the value of the X. The value of X will be the user input value, and that is not in the list, that will be displayed. So this is how the program for linear search works. Initially, it reads in the values for the linear search, I mean the linear array, as well as the value that is to be found out. Then it checks whether this particular value is present in the array or not. If it is present, then the control is broken, the for loop is broken, and it displays the value is found. Then if it is not present in the list, then what it does is the for loop is terminated by ending or by reaching the point I less than n minus 1, and then it prints this particular value is not in the list. So that is how this particular program runs. So let us see how this program runs. So the first, it displays how many numbers in the list. So I am putting 6. So there will be 6 numbers in the list. Enter the numbers. The integer values are to be entered now. So 6 numbers I have entered, 1, 2, 3, 4, 5, 6. The 6 numbers we have to enter because we entered that the number of elements in the list is only 6. So we have to insert or we have to enter 6 numbers here. Now we have to check, we have to enter the number to be searched for. Which number is to be found out, whether it is present in the list or not. Initially I am giving 26. So 26 is in the list, that we know. 26 is already in the list. So it is checking 26 is compared with the 58 and it is not equal. 36 is compared with the 26, not equal. 42 with the 26, not equal. 51 with the 26, not equal. 26 equal to 26, it is equal. So at this position, when 26 becomes equal to 26, the for loop is broken and the result is displayed, that is 26 is in the list. So that is how the linear search works. So now let us consider another example of running the program where the number is not in the list. So 86, 35, 26. Oof. Actually, I put a wrong message here. How many numbers in the list? I put it as 86, so it will create an error. So I am just terminating it. Then again, I am only 6 numbers. 6 numbers I am putting: 89, 65, 32, 12, 54. Enter the number to be searched for. I am searching for 12. 12 is in the list. So this is how the linear search works, comparing one element at a time with the key value that is to be found out. So any doubts regarding this linear search? And this is again another problem involving one-dimensional array. Only a single subscript is present in the arrays that we considered till now, and those type of arrays are known as single dimensional arrays because the elements spans only in one direction. If you have no doubts, we move on to the next topic. Okay. The next topic is about the multiple subscripted arrays. Multiple subscripted arrays are the arrays which can have more than one subscripts. In the previous case, in the case of A, the case of the array A, what we have seen is only one subscript was there, AI. So if there is one more subscript, say AIJ, so this is here there are 2 subscripts. So this is a special condition for multiple subscripts, that is with the 2 subscripts. There is possibility of any number of subscripts as long as the system in which this particular compiler works supports it. So theoretically it is infinite, the number of subscripts that is possible in a possible for an element, or I mean for a particular variable, the number of possible subscripts for a variable in C is theoretically it is infinite, but there are some restrictions based on the system that is being used or the compiler that is being used. But anyway, for our almost all the practical purposes, the number of subscripts that is available is sufficient. See, this is I is one subscript, J is another subscript, and K is the third subscript. So this is a three-dimensional array. It will be a three-dimensional array, or it is known as multiple subscripted arrays. So this multiple subscripted arrays can be used in order to represent values in a table. If there are only two subscripts, I and J, if there are two subscripts, then I can be used to represent the row number I equal to 0, I1, I2, etc. That is the row number, and the second value, that is the J value. The J value can be used as the value or the index to represent the column value. So this is 0, 1, 2, etc. So 0, 0, if I am writing A 0, 0, this means the value at this position, If I put A0, 1, A0, 1 will be the value at this position. A0, 1, 2, that value will be here. A1, 0, it will be here. A1, 1, here. A1, 2, here. A2, 0, here. A2, 1, A2, 2, etc. This is how the multi-dimensional arrays can be defined. That is, more than one subscripts are possible in the case of multiple subscripted arrays, or also known as the multi-dimensional arrays. So, in order to find out or to identify a particular table element, what we have to do is we have to specify two subscripts. The first subscript, it identifies the elements row, and the second identifies the elements column. In a table it will be like this. So there are multiple rows as well as multiple columns. This is a row, and this is another row, and this is another row. So this is a column, and this is another column, and this is the third column. So when a value like A1, 2 is to be accessed, it should first go to the row with the index number 1. So this will be the row with the index number 1. Then it should move on to the column number 2. Column number 2 will be, this is column number 0, will be 1, and this will be 2. So that is how the values in a table or in a two subscripted array, or a multi-dimensional array with the indices 2, with the two indices or two subscripts are assigned, are accessed. So tables or arrays that require two subscripts to identify a particular element are called double subscripted arrays. So here there are two subscripts, so it is also known as a double subscripted arrays. So this is an example of a double subscripted array. So this is the row 1, row 0, then row 1, row 1, then this is row 2. Here it is column 1, this is column 1, and this is, this is column 0, and this is column 1, column 2, and column 3. If you look carefully into the elements within this particular table, you can see for the first row elements, the first subscript is 0. So this is 0, this is 0, this is 0, and this is 0. So all the first subscript in the first row that is row number 0, will be equal to 0. And for row number 1, that is the second row, for the second row of the row number 1, the first subscript will be 1, 1, 1, 1, 1. So this is how we identify an element in a multiple subscripted arrays. So if you want to access the element at this position, you have to use the subscripts a of 2 and 1. So this is for a 2 or double subscripted arrays, but the number of subscripts can be more than 2, no problem. So generally an array can be termed as m by n array if there are m rows and n columns. If there are m rows and n columns, it is commonly known as m by n array. This array is a 3 by 4 array because it has 3 rows, 1, 2, and 3. 3 rows and 1, 2, 3, 4. 4 columns. So that is why it is known as a 3 by 4 array. So that we have already discussed, every element in array A is identified in figure by an element name of the form Aij, where A is the name of the array and I and J are the subscripts that uniquely identify each element in A. Sorry. The names of the elements in the first row. In the first row will have a first subscript of 0. The names of the elements in the fourth column will have a second subscript of 3 that we have already discussed. So again, a multiple subscripted array can be initialized when it is defined much like a single subscripted array. So for example, a double subscripted array into B22. So this is an array. B22 is a double subscripted array. So int means it contains only integer values. Could be defined and initialized with int B22. So this is the size of the arrays. I mean size of the array in the row direction as well as in the column direction. That is, it will be having 2 rows as well as 2 columns. It is something like a square array, which is having 2 rows as well as 2 columns. And these 2 numbers, the numbers are normally put inside double braces, and each row is again inserted inside double braces. So this is the first row, 1, 2 will be the first row, and 3, 4 will be the second row. So the values are grouped by row. The values are grouped by row. That is, all the numbers in a particular row will be put inside a double brace. Then we will put a comma. Then the second set of values for the second row will be put. So 3 and 4, that will be the second row. So if we are considering this one, it will be something like this: 1, 2, 3, and 4. This will be the array, that is B equal to this particular array, 1, 2, 3, and 4. So this is B00, this is B00, and this is B01, this is B10, and here it is B11. So this is how the elements in an array are initialized, in a multi-dimensional array are initialized. The values in the first set of braces initializes row 0, and the values in the second set of braces initializes row 1. So that we have already seen. So the values 1 and 2 initialize the elements B00 and B01 respectively, and the values 3 and 4 initialize the elements 10 and 11 respectively, that we have already seen. Now, if there are not enough initializers for a given row, suppose something like this is happening, that is only one element is coming up in a double brace, but the number of rows is 2 as well as number of columns is 2. So if there is only one element is present in the first row, then obviously the remaining elements will be initialized to 0. So if this is the condition, then B will be initialized as 1, 0, 1, 0, then 3, 4. This is how it is being initialized. So this is because here there is only a single element present, So B00 will be initialized to 1, B01 to 0, and B10 to 3, and B11 to 4. So this is how the multiple subscripted arrays can be initialized. This is another way of initializing the multiple subscripted arrays. Or there is another way of initializing the multiple subscripted arrays, that is by giving the input. The values are input by the user. The user can input the values one by one. So in that case, what you have to do is you have to use two different for loops, one nested within the other, or two different for loops. One is nested within the other, and one for loop is to trace through the rows, and the second one is to trace through the columns. So you can input each value one by one. So that is also possible. Now let's see how to find the transpose of a given square matrix. So obviously the multiple subscripted arrays or the double subscripted arrays can be used to represent matrices. The matrices, you know, it is a two-dimensional array of values, two-dimensional array of numerical values. So if we have a matrix like this, a square matrix means the number of rows equal to the number of columns. The number of rows equal to the number of columns. If we have a square matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a square matrix. The transpose of this particular matrix is, the rows are converted into columns. That is 1, 2, 3 in the row. That becomes the first column. So 1, 2, 3. So this row is converted to column. Then 4, 5, 6. The second row is converted to the second column, and the third row 7, 8, 9 is converted to the third. So this is how the transpose of a matrix is found out. So if we watch closely, the first column is converted into the first row here, second column is converted to the second row here, third column is converted to the third row here. So the row and the columns are interchanged in order to find out the transpose. So how to find out the transpose of a given square matrix? That is our next problem or the next program. So let us see how this is possible. So in this case, actually we are using two input files, stdio.h as well as the conio.h. Both are input-output files, but stdio.h is sufficient. But in some systems, if you doesn't use conio.h, the puts may not work. That is why it is included here. It is not necessary in my system. In my system, in order to work the puts, only stdio.h is sufficient. But in some systems, it may not work. So now we start the program with the main. Then we define a matrix, float MAT 2020. So that is the maximum size, the maximum number of rows is 20 and the maximum number of columns is 20. Then we defined three variables, A, B, and N. They are integer variables. The matrix is defined as float variable, and these three elements are I mean, these three variables are defined as integer values. Now we give the order of the matrix. The order of the matrix is the number of rows or the number of columns. In the case of a square matrix, the number of rows equal to the number of columns. The order of the matrix is equal to the number of rows and number of columns itself. So then we scanf the value. The number of elements, I mean the number of rows of the matrix is read. So it will only a single value is required because the number of rows will be equal to the number of columns. Then what we displace is give the elements of the matrix row wise. The number of elements or the elements within the matrix is entered in the row wise. That is, the first row should be entered first. If the in the first row, if it is 1, 2, 3, then it should be displayed. So then in order to scan that particular value, that is, in order to input that value, we need 2 for loops. 2 for loops are required. In order to control the for loops, we use the variables a and b. So for a equal to 0, a less than or equal to n minus 1, a plus plus. For b equal to 0, b less than n or equal to n minus 1, b plus plus. Then scanf percentage f. Since it is a float value, in the matrix it is float value percentage f ampersand mat a b. So this is a is for the first subscript and b is for the first subscript. When a equal to 0, b traces from 0 to n minus 1. B traces from 0 to n minus 1. So mat 0, 1, 0, then 0, 1, mat 0, 2, 0, 3, etc. All the values up to n minus 1 are first read. Then the next value that we entered will be a equal to 1. That is, a is initially 0, then a becomes 1. Then when a becomes 1, it will be reading a1, 0, 1, 1, 1, 2, etc. So this is how the matrix is read into the program. Then we put the original matrices. Then it displays the original matrix. In order to display the original matrix, we again use 2 for loops. For a equal to 0, a less than or equal to n minus 1, a plus plus. A new line character is required here. This new line character is required. That is, after each row is printed, the carriage has to be returned, or the control has to be returned to the initial position for the second row to be displayed. That is why we are putting a printf /n, a new line character is printed. Then what it does is, an element is printed and then a tab is printed. So that is percentage f is to print a particular element, and then /t is to give some number of spaces in between these two elements. In between two elements, we need some specific amount of spaces. Then only it will appear. It will appear as a matrix. So that is why we are using this. Then what we do is we print the statement that is the transposed matrix is. And in order to print the transposed matrix, what we do is we again use the same, almost the same statement is used. The for a equal to 0, a less than or equal to n minus 1, a plus plus. Then print /n. For b equal to 0, b less than or equal to n minus 1, b plus plus. Then print of percentage of t. Until this, it is the same. Everything is same. But when it comes to the value that is to be printed, instead of mat a b, it reverses it. That is, mat b a comes in action. So that is, initially the values in a particular column will be displayed. The values in the column will be displayed, then the values in the row will be displayed. So values in the column will be displayed in a row wise manner. The values in the column will be displayed in a row-wise manner. That is, all the values in the column, in the 0th column will be displayed in the first row. That is how the transpose is being done. Now let us run it. So give the order of the matrix. I am giving only an order of 3. Then give the elements of the matrix row wise. I am giving the matrix 9, 6, 5, 3, 2, 1, 7, 4. Okay. So now see the original matrix is 9, 6, 5. So the first 3 elements 9, 6, 5. Then 3, 2, 1, 3, 2, 1. Then 7, 4, 8, 7, 4, 8. So this is the original matrix. On top, it is the original matrix. And on the bottom, it is the transposed matrix, 9, 6, 5. So it is in the column. First, what it prints is the first column, 9, 3, 7. 9, 3, 7. It is displayed. Then the second column is displayed, 6, 2, 4. Then the third column is displayed, 5, 1, 8. So this is how the matrix is transposed in C. That is, we can test the transposition just by interchanging the indices. Just by interchanging the indices. In the original matrix, if it is mat A, B, in the transposed matrix, it should be the mat BA. So that is the way how the transposing is done in C programming or using C programming. And that's for today. We will continue in the next week or the next session. Any doubts? Any doubts regarding the multiple subscripted arrays or the transposition of or the finding the transpose of a matrix? And finding the transpose, the same procedure is applicable in the case of non-square matrices also. Same condition for finding the transpose is applicable for a non-square matrix. So in that case, the end index will be different. That is the only case. Suppose there will be an index m by n. So m for row and n by n for column. Then that you have to check. In the for loop, that much you have to go. That is it.